Hello, good day. Today we will be discussing another aspects of curvilinear motion, but this time we'll be using the normal and tangential components. So if you recall, last time we used to solve the curvilinear motion using the rectangular components. Okay, so we resolved the components of the velocity and acceleration along the x and y components. However, this time we'll use the normal and tangential components. Okay, so if you look at your book on page 53, you have this particle. Okay, so it moves along this curvilinear path. Okay, so you need to define the origin or the O. Okay, so this is the starting point of your particle. Okay, and this S represents the displacement. Okay, so in the normal and tangential components, we resolve the components of the velocity and acceleration along the tangent to the path and normal. Okay, normal or perpendicular to this tangent axis. Okay, so in order to define this axis, we need to have a unit vector that points towards this direction, and also a unit vector pointing in this direction. Okay, so since this is a unit vector, the magnitude is 1, and for this normal component, this is positive if you are approaching the center of curvature. Okay, so this is the curve, so somehow parang may center yan dito, so going here is the positive direction. Okay, so unsa ang mga importanteng parameters ani? So you need to have to define the radius of curvature, or this one, rho. Okay, so there is a formula given aning rho. We will show that later on. Okay, and this is the displacement. Okay, ds, small ds, or this arc length. Okay, so let's move with the velocity. In determining the velocity, okay, the velocity is always tangent. Okay, tangent sa imo ang path. Okay, so this is your curve, so you draw a tangent line from that, diha ang direction sa imong velocity. Okay, and then if you differentiate that one with respect, by the way, so in this part, ang kaning S nimo would be, you will have something like S as a function of time. Okay, you'll have an equation that looks like this. Since this is a function of time, if you differentiate that one, you will get the instantaneous velocity. This one, the instantaneous velocity. Okay, so here are some important points, or the special cases of motion. First is that if the particle moves along a straight line, okay, straight line sample, this one. So from if the particle travels along a straight line, then the normal component of acceleration is 0. Okay, 0. Why? Because there is no, wala may curve, no? So may tabo kung straight line, di mo balik ka dito sa equation sa rectilinear motion. Okay, diba sa rectilinear motion wala may component along normal. Okay, so ang imong acceleration would be the tangential only. this one. And we can conclude that the tangential component of acceleration represents the time rate of change of the magnitude of the velocity. Okay? Now, if the particle moves along a curve with a constant speed, okay? So, sample this one. If the particle moves along a curve at a constant speed, what is the implication? The implication is the tangential component is 0. Okay, always remember this one. Okay? If the particle moves along a curve with a constant speed. Okay, as you all know, the acceleration is the change of velocity with respect to time. So if the velocity is not changing, therefore, the tangential component will be 0. And the acceleration is just the normal component, which is v squared over rho. Okay? Therefore, the normal component of acceleration represents the time rate of change in the direction of the velocity. Since acceleration normal always acts toward the center of curvature, this component is sometimes referred to as centripetal acceleration. Okay? Okay, so if you have a three-dimensional motion, by the way, okay, so since kanina you are just studying two-dimensional, however, if three-dimensional na siya, so you will add a component along this B. So ang tawag niya is binormal axis. Okay, so imagine ka tong ganina is planar pa to siya, so diri pa ang imong motion na to, wala kay third axis. So ang acceleration is defined only along this normal and this tangential direction. However, if mo involved na og three-dimensional, meaning moangat na ning particle nimo, so important to know this binormal axis. Again, by using right hand rule, the cross product of the tangential cross normal will give you the direction of the binormal axis. Okay? So let's proceed with the acceleration. Okay? So the acceleration of the particle is, you just differentiate the velocity. Okay? This one. So if you differentiate this one with respect to time, you will get something like this. Okay? You need to apply product rule. So b dot u sub t plus v u sub t dot. Okay? Meaning anong u sub t dot? Change of the unit vector u sub t with respect to time. Okay? So kung ato nang i-draw ang motion niya, first na diri mo ang object, and then at a certain time na siya diri. So mo change na karon ang imo ang u sub t. Okay, by the way, ang imong u sub t and u sub n ga change na siya depende sa iyang location sa imo ang curvature. Okay, so first diri ang iya ang tangential component, then there's some time diri na. So the question is, what is the change of this u sub t with respect to time? So mao ni siya. We need to get the value of this one. Okay? Okay, so in order to get that one, okay, always remember nga kaning u sub t is 1 asya, no? Kung ato ning i-draw, okay, this is u sub t, so represented by this line. And then at a certain time, 1 unit imong superimpose dere, i-maintain mo ang angle nilang duha, no? This one, the angle between the two, muna d theta. Okay? Since ang u t o u prime of t 1 man ang value nila. Okay? So therefore, ang change sa imo ang du sub t is this one, no? So unsa ang value ana kung imo ning i-differentiate with respect to time, unsa may mahitabo, du sub t is just okay, du sub t. So unsa ibuhaton nimo ani? You just apply the length for the arc length, no, ang arc length ani niya, anyway kay very, very small man ni siya, so makita nimo nga du sub t, di ba, ang value kung naa kay, say for example this one, unsa i value aning ds, ang value ani niya, di ba, is just ang angle dere d theta times d radius, no. So in the same way ani, ang value sa du sub t is just equal to d theta times 1, kay 1 man yung length ani, so mao ni siya d theta times 1. Okay, and then that is the magnitude. Unsang direction? Ang direction niya is same sa direction sa u sub n, so mao ni diri nigikan d theta u sub n. So ang value dayan ni is just, again, imo ning with respect to time pa man ni differentiate nimo ni with respect to time, you will get this one. Ang value ani niya is theta dot u sub n. But remember that theta dot or this one kani unsay value ani, that is just ds, or ds is just rho d theta. So imo ning i-substitute karon dire, no. Ang value ana niya will be u sub t dot is just theta dot u sub n, but theta dot is just s dot over rho. That is why ang value de ani niya is just v over rho. Anong v over rho man kani, kay kuan man ni velocity man ni v over rho. So mo na dai ni mo nang i-substitute there, you will get this formula. So makita nimo, you have the tangential component of acceleration and the normal component of acceleration, which is v squared over rho. Okay? So mo na siya. This is the tangential component, this is the normal component. I-add na nimong duha, you will get the acceleration, also the magnitude kani using this equation. Anyway, we will have an example in order to demonstrate this one. Okay, by the way, kung dili given ang rho, makuha mo siya ani, no, ani nga equation, as long as sa may requirement ani given nga ang path is y is function of x, no, given ni nga equation dapat para makuha nimo ang rho. Okay, sample kaniyo. Question ani is unsa din ning rho ani. So using this equation, so dapat na kay equation na looks something like this: y is equal to function of x. We start with the example. Let's first derive the formula for velocity and acceleration. Okay, so if you recall, this is your object. Okay, so the component of the velocity is, you have the velocity along the tangent of this curve. Okay, that is your velocity in notation form. Okay, so this u sub t. Okay, so this is your velocity. So pwede po na ito butangan o aron nila na to remind ourselves that this is a vector. Okay, and then if you want to get the acceleration, you just differentiate this one. Okay? So this becomes first, or rather second the first ut plus first the second. Okay? Okay, kani, may problema ni kay may value. This is just the acceleration tangential. Kani, we need to get the value of u sub t dot, or this is just equal to the u sub t with respect to time. Okay? Okay, so looking at the figure sa inyong book, initially, if this is the initial position of the vector or the particle, okay, you have this is your u sub t, right? And then this is your u sub n. Okay? Again, this is the radius of curvature. Now, kung sa may tabo kung maabot na ni dire, ano po kay tangent na po dire, same magnitude. So tangent kani sila o kani dapat the same, u sub t prime, and this is your, again, this is your u sub n prime. Okay? Now, ang length ni this is your d. Yes. Okay, kung ato ni siyang i-superimpose para makuha, ang objective na to is to get this one. So, ito ni i-superimposing diba. So, you have u sub t, and then perpendicular na niya na kay u sub n. And then kani, kung butang diri, na this is u sub t prime. Okay, so ang kaning change ani, kani siya, mo na ang change of u sub t. Right? Okay, so the value ng du sub t. Du sub t is just kung saan angle dere. Ang angle dere is just d theta. The same way dere, d theta gapon na. Okay? Okay, so this will become ang magnitude ng u sub t, diba? Theta then r. So ang rate, ang r na theta r na. So ang theta is d theta. Ang r nimo is just 1 times 1. Okay? Okay, so this becomes, differentiate natin ni with respect to time. You will have no. Kulang pa din eh. Kulang ni siya ang direction. This is the magnitude. Ang direction niya, the direction would be same sa u sub n, no? Same direction, so u sub n. Okay? Okay na. So this becomes u sub n. Okay? Okay. And then, sa value ani, paitan po natin sa value ani. Makuha natin na using this relation kani. Using this relation, this is 0, this is ds, this is d theta. So, makuha nyo doon ds, this is just rho d theta. Right? Therefore, d theta is just 1 over rho ds. Again, differentiate mo na with respect to time. D theta over dt is just 1 over rho ds over dt. If you recall, running ds over dt, this is just the velocity. Therefore, kani di is just v over rho u sub n. Okay? Kani. So, ang pasabutan equal ro din sa v over rho u sub n. So, ito nang i-plug in dere. Again, denoting that kaning tangential component sa mga acceleration is just b that may maning 80 u sub t plus v times kani v may mga v squared over rho u sub n. Again, may maning 80 u sub t plus an u sub n, where an is just v squared over rho. That's it. Huh? Okay, so proceed with the example. Okay, so let's have this example. Okay, so let's have this example, and you have a box that travels along the industrial conveyor. If the box starts from rest at A, okay, so this is point A, and increases its speed such that the tangential component of acceleration is 0.2 times t meters per second squared, where t is in seconds. Determine the magnitude of its acceleration when it arrives at point B. Okay, so this is the point B. So we are asked to determine the magnitude only, no? Magnitude. So, okay, so unsa unang bato na to? Acceleration B is composed of acceleration B tangential plus acceleration B normal. Okay? Normal. So, what do we do? Okay. We know that the acceleration of A is given by this one. AT is 0.2 t. Okay? So, mauna siya. That is the given. And then, for the normal component, normal is just v squared over rho, wherein the rho is 2 meters. Okay? So, we need to get the velocity at point B. Dire. No, kaning velocity of B. Velocity at point B. So, sa itong buhaton na how do we get that one? We need to get that from here. Okay? So, AT is just dv dt. Okay, therefore, dv is just 0.2 t dt. Evaluate from 0 kay starts from rest man. 0 to velocity of B. Okay? Kani from 0 to t. Kaya wala mong takabalo ano sa kataasan nag-travel diha. So therefore, velocity of B is 0.1 t squared. Okay? So that's it. Nakakuha na tawag expression for B, but we need the time. Saan isa nga time? Time from dire, tama na abot dire ang box. So sana sa pagkuha. Let's recall that velocity is ds over dt. Okay? Given tau velocity, and also we are given the displacement. No? So the displacement is, okay, if we will evaluate this one, ds is just velocity of b dt. Integrate this one from 0 to t, this one from 0 to s sub b. Okay, therefore s sub b, I don't know. Okay, tama. S sub b is just yan integral of 0.1 t squared dt. Therefore s sub b is 0.1 over 3. 0.1 over 3 is 0.1 over 3 is 0.1 over 3 is 0.0333 t cube. Okay? Okay, but we know kaning is sub b. Kaning s sub b is kaning length. No? S sub b is just 3 meters plus quarter of a circle. Circumference ana, no? That is just theta r. Theta ni is 90, so 90 degrees 90 degrees, convert na to 100 to radians times 2. Okay, so that is just pi 6.142. Okay, therefore 6.142 is just 0.0333 t cube, or the time is just 5.69 seconds. Okay, 5.69 seconds. So meaning from 0 pag abot og 5.69 naabot ta diri imong box. So wala na ilain, no? Therefore ang imong velocity will be 0.1 5.69 squared. Your velocity v now is 3.238. Okay, 3.238, and then ito na substitute diri over rho. Your rho is 2, right? So 5.242. Now for your acceleration tangential, mo lang substitute ang time diri. 0.2 times 5.69. So this is just 1.138. Okay? Now, since pangtaan tawag magnitude, so get the square root of 1.138 squared plus 5.242 squared. This will give you 5.36. Okay, therefore the acceleration at point B is 5.36. Okay, so unsa nimo pagkuha ang direction? Direction niya will be theta is just normal. Ilang normal? Tangent inverse of 5.242 over 1.138. Oh, kabulkila na siya, but paano na siya dari? Okay? So dari ang imong acceleration at point B. Okay? So that's it. And naidagang example there sa book, just solve this one.